Number of dash is being cut out, the top part.
For now it's okay, I think. Yeah. Sometimes you may need to quick. Sorry for the trouble. Hi, good morning everybody. So, yeah, we have quite a small class today. I hope other people are enjoying their good morning. That's a real good morning, right? Alright, so I wanted to point out one thing. If you have not noticed it earlier, if you look at the mark distributions that will follow in this course, you'll see that we have a homework, projects, quizzes, exams, and all of them will add up to your total grades, right? So the homework carries 25% mark. The quizzes that you attend in every Wednesday, that also carries 25% mark. The exams, that carries 50% mark because we have 3 exams, and if you remember that out of 3 exams, the best 2 will be counted. Okay. So one of the exam is very knocking at the door. It's at October 1st. Okay. I'm yet to figure out that whether it will be October 1st or October 2nd, but within that time frame, maybe plus or minus 1 days around October 1st. So be prepared for that. But apart from that, I probably did not talk about the other part, the project, which also carries 25% mark. And if you add up all of them, you see that the total value is actually 125%. So this means that if you do the project, you can get some bonus points. Okay? For instance, I know that sometimes we happen to do not do very well in exams because of time pressures and some other stuff. So I have seen people from my previous experience that who is actually very good in their own disciplines, but somehow when it is the exam, because of all this mental pressure, they cannot do well. They cannot think in a very short period of time. But it's possible that if you give them enough time, they might be able to think about it, and maybe they will be able to come out something good. So, in order to accommodate that, I wanted to give you an opportunity that if you can do some projects, that of course every project will be done single-handed by your own self. You can talk to people, but everything has to be done eventually by you. And the project carries a very big amount, 25% mark. So it means that even if two of your exams is very bad, still you can cover it up by the project. Okay. But the project would be very challenging, but it will be fun, I believe. Okay. So what kind of project we are talking about? I think up to this point, we didn't talk about the project because at that point it didn't make any sense. But now you know a little bit about it, so you are more mature to understand how to deal with this project. So one of the projects could be the following. I talked about it a little bit previously, that if you have a printer, the way the printer works is that they have some electrostatic control on the droplets of inks, and by changing the voltage, you can steer the droplets dimensions, the droplets trajectory. So this could be one of the projects. The other project could be particle accelerator. So particle accelerator is something that maybe we have not talked about too much. Yeah, we were talking about that yesterday, dude. That's So, guys, I want to have your attention here. So, what we see here is some pictures of particle accelerators, and the way particle accelerator is used here, specifically in this picture, is to treat cancer. And the way it works is the following: that you know that cancer basically means your tissue cells, your body cells that doesn't really abide by any rules. So it has a very peculiar DNA, and it grows with its own terms and conditions. So that's why it becomes very aberrant, very anomalous. So if somebody got cancer, the way people try to treat it is that they try to kill that cancer. Okay? Now there are many possible ways of killing the cancerous tissues. One possible way is that you take some drugs. The problem is when you take the drugs and it mixes with your blood vessels and goes to the other organs, apart from the cancerous tissues, it can also kill your good tissues. Right? So people try to think about new ways, like how we can really solve this problem. So other possible way is that instead of taking medications, drugs that goes along entire organs of your body, what if you can target that which particular cells of your body is problematic, and can you kill it? So particle accelerator is designed in order to help us in that way. You know that each of the cells, they basically are governed by their DNA. So when you have cancerous cells, that means the DNA of the cancerous cells is actually different than the other good part of your body. Now, if we can break those DNAs, that will help us to kill the tissues. So how are we going to break those DNAs? You have heard about DNA, right? Okay. So if you haven't heard about it, it's okay. I mean, not every one of them have the biology background. So let me explain a little bit about it. So in our body cells, in our body we have cells. The size of the cell is roughly around 10 microns. It varies. The size also varies. For instance, the cell of our neuron is much larger than the other body part of the cell. So typically, 10 micron is a good point to start for the cells. And inside the cells, we have nucleus. And inside the nucleus, we have nucleolus. So let me write it this way. So this is a cell. This is nucleus, and this is nucleolus. And the DNA is actually right here. It's a very long line of thread, and this DNA contains the code, like it's like the programming code that eventually controls everything in our body, like how do we look like, even how are we as a person, everything is encoded there. So these DNAs are actually very thin, and they're very tightly packed inside the cells. If you take those DNA strands and make them elongated, make them stand out, do you know how long it will be? If you take just one cell from your body, and somehow you're able to extract the DNA straight from there and spread them out, you can actually wrap the entire Earth 7 times by the DNA chain. So it's amazing that how long this DNA chain is. One single cell, and you can wrap around the Earth 7 times. So it's actually pretty huge amount of code there. And if the cells becomes cancerous, then those DNA structures get changed. So people try to find out that which cells are particularly problematic in our body. And they think that what if they can bombard those cells by some high energy particles. You know, since the DNA itself is very thin and narrow, I said that if you expand it, it will be very long. So in order to hit that, you need also something that's also very small. So the smallest amount of thing that we know is probably, what is the smallest thing that you know of? We talked about it in this class a lot. Pardon? Say.
Never mind, I'm sorry.
What is the answer? Electron. So electron might be the most effective way to hit this guy. Now tell me this. If I hit you with this guy versus if I hit you with this guy, take this entire table like Hercules and throw it on you. Of course, the second one is going to be more effective. Why? Why the second one is more effective? Tell me from the physics point of view.
More mass.
More mass. So, if I have more mass, go ahead. What equations will be there to explain the trajectory of it?
Force.
Force, exactly. So, if I have the same accelerations, then this guy is going to have more force. Force is equal to mass times acceleration. So, people thought that we can control electrons very well. But the problem is the electron itself is very light. So if you bombard this guy, his cells, with electrons, maybe you won't see any effect. Let me write out the corresponding value of electrons. So the mass of an electron, let me write the charge first. The charge of electron is 1.6. 10 × 19 coulomb, and the mass of electron is actually 9.1, if I am not mistaken, multiplied by 10 × 31 kilograms. So people realize that if you are going to use electrons, they are not going to be very effective. Okay? But apart from electrons, we know there is one more thing that are much more heavier than electrons, and that's also very small in size. Do you know what it is?
Protons.
Protons. And there is also one more thing that's also very heavy. Neutrons. So protons and neutrons both are very heavy compared to electrons. Okay? So maybe those would be a better candidate if you try to bombard those cells with protons or neutrons. Now there is also one more thing. Neutron has no charge. So this means if you put a proton and a neutron in an electric field, the neutron won't react. Okay? But the proton will react. If you place proton in an electric field, the proton will try to move away from it. If it's a positive field. If it's a negative field, proton will try to move the other direction. So people think that since proton has both this quality, proton is very heavy and proton is very small, and also proton reacts if you put it in an electric field. Maybe proton is the best possible candidate to use it in a particle accelerator and try to bombard this proton into a cancerous tissue. Are you following? So this is why these guys, they try to design some particle accelerators, and these are the chambers. Okay? These are the chambers. And inside that, they have the fields set up in order to guide the proton to your desired cancerous tissues. So, the charge of the proton is also 1.6 10 × 19 coulomb, and the mass of proton, I think I forgot.
1.67 times 10 to the negative 27.
Tell it one more time, please.
1.67 times 10 to the negative 27.
This one? Is it kilogram
Yeah, I think so.
or gram? Kilogram? Okay. Thank you for pointing out. So you can see from here that the mass of electron is 10 × 31. Don't look at this guy. is too small. Just look at the exponent. 1 is 10 inverse minus 31 and 1 is 10 inverse minus 27. So this guy, the proton, is 1,000 times heavier compared to an electron. It's very, very heavy. So this is why people thought that maybe proton is the best possible way to utilize and bombard the cancerous cells. Now, how we are going to accelerate those protons and give them sufficient energy? Remember that when we talked about accelerations requires you to create some force. And how can we create force? Let us say that we somehow have charge on two bodies, let's say Q plus and Q minus. So those two charge will create some electric field. Right? Those electric field will be distributed like the following way. So the field goes from the positive charge and end up to the negative charge. And if you put some test charge somewhere here, let's say you put some small positive test charge in that electric field, which direction of trajectory to take? Would it go to its right or would it go to its left? What is your thought? To the right, because it's a positive charge, right? So it will always try to go away from the positive guy and go towards the negative guy. And we can also calculate like how much acceleration we can have out of these small test charges. So in order to know the acceleration value, we're trying to find out the acceleration, and that's why we need to know what is the force acting on that small test charge. Now, how are we going to find out the force? We know how to calculate the electric field, right? So, tell me the problem. How we are going to find out the corresponding electric field at the test charge Q at a distance d? We know if we are going to find out the electric fields, we can use the principle of superposition. That means we can imagine that this guy is absent. So all the electric field is coming from this guy. And we know that this guy is going to have an electric field that corresponds to kq by d square, right? And then we will simply add up the contribution from the other guy. The other guy, let's say it has a minus q charge. So it should also be kq divided by d square, right? Should I also write d here? Or should I write something else? If this test charge is d distance away from the positive charge q, I'm going to write kq over d square for the contributions from the positive charge. For the negative charge, I also need to look into the corresponding distance between the negative charge and the test charge, right? So that will be something different, correct? So let's say that this is also, let's say the first one is d1, and the second one is d2. So that means we need to write the two contributions from these two charges in the following way: kq over d1 square and kq by d2 square. Am I going to just add them up? Just add, just use a plus sign, or do something else? Like let's say that this guy is like 1 Newton, and this guy is maybe 2 Newton. So I just add them together? Or do you think we need to do something else?
You need to use vector addition.
Say it again.
You need to use vector addition.
Vector additions. Don't forget that. So we have to add them by considering that these are vector properties, right? So it's not a simple addition. It's simple algebraic addition. We need to take care of the fact that they are angular. So they have some x component and some y component. So that's why instead of simply adding them together, we are going to divide them into two components. Okay, so the first guy will have some x component and some y component. And the component is just written alpha 1 and beta 1. Okay? We can figure it out that what is the component. In order to figure out the component, we simply need to see that what is the corresponding angle between the force and the x-axis. So, if the angle is theta, then the corresponding x-axis component of the force would be cosine theta of x. So, alpha 1 would be cosine theta, and beta 1 would be the other angle, that is sine theta. In a similar way, when we shall add the contributions from the negative side, we also need to take care of that. These guys have a different distance from the test charge, so I use a different value of d2, and also I have a different component a2 and b2 for the x and y axis. And then we will add them together. Okay? Once you divide them into components, you can simply vectorially, you can simply algebraically add the alpha 1 and alpha 2. So eventually the result would be eventually this is how we are going to calculate the entire stuff. But remember that we are only considering that the entire plane is 2 dimensional. In reality, it will be 3 dimensional, right? So you have to add one more component, but you get the idea that we eventually we have to divide all these vectors into x, y, z component, and then we are going to add them together. And also remember that once you have some force, then depending on the force, they are going to have some accelerations, right? Because they will also have some mass. So if it is a proton, the proton has a mass of 1.67 into 10 inverse 27. We are going to put them this value here. You know what is the value of F? We just calculated the value of them, F. So this is F. In fact, probably I should say that this is electric field. And in order to find out the value of F, we simply need to multiply the electric field with the point test charge, small q. Okay? Then we will get the force. And once we get the force, we will divide them with the mass, and then we will get the accelerations. Once we have the accelerations, remember that this guy is going to move around, right? So it will move to its right. Once it moves to its right, then the value of d1 and d2, they are going to change. Yes?
Why is the electric field equation there? Why is it the y term? Why is it just over d2 squared?
Oh, you mean this one? Is it correct now?
Well, that's what I'm wondering is why is it not over, like, why is the first one not like,
Oh, isn't the same
d1
thing?
squared minus d2 squared, and then the second term is also,
Oh, this is the same thing, right? Like, I can also write it different.
so we're saying d1 and d2 are the same?
Yeah, isn't it the same?
Okay. Alright.
It's the same thing.
Are we assuming they're equidistant? Or D1 and
No, they are not equal. They are different, right? So previously I just wrote it by chucking it up into 2 different terms, and I can also write it in the same term. They're same things, right?
Yeah, but when we combine like terms by the unit vectors, shouldn't they be in different terms?
So one of the terms is k cubed by d square multiplied by alpha 1, and you are going to algebraically add k cubed by d2 square multiplied by alpha 2.
Right.
Right? Oh, I see.
Yeah.
I see what you're saying. I'm sorry.
Good.
I'm sorry.
Thank you. I'm really crazy.
I'm so sorry. You're correct. Does it look correct now? Okay, I'm so sorry guys, but thank you for pointing it out, and thank you for being so vigilant. I appreciate it.
I'm sure if I was missing something here.
No, thank you. Sometimes these silly things happen, and it misguides people, but thank you so much for pointing it out. So, going back to our discussion, once we get the electric field, we can calculate what is the corresponding force, and once we get the corresponding force, we can use this equation to find out what is the corresponding acceleration. Right? So once we find the accelerations, then I know that this Q guy is going to move around a little bit, so I need to find a different position of the Q after some time t. And which equations am I going to use to find out the position of Q after time t with that acceleration a? We're again going to use some Newtonian equations, and the Newtonian equation says that V is accelerations multiplied by the time, and the distance is V multiplied by the time. Okay? So, if I tell you that we have some accelerations, and let's say after 1 microsecond, in which velocity this guy is going to attain, we will use the first equations, and if we use the second equations, we will know that what is the new position of this small test charge Q after a certain time t. So after every small time frame, they will have their new value of accelerations because they will change their positions. Okay? So this is something that we need to calculate through programming, then eventually we will see that what is the entire trajectory, how this small test charge would move from one place to another if we keep it in an electric field. Okay? So this would constitute a small part of the project. Right? If you put a test charge in an electric field created by plus Q and minus Q charge, how this small test charge is going to propagate along the entire electric field. Okay? And your project, I mean, I think that the best way to do this project is to use Python programming, or you can use your other favorite language, absolutely open. You need to have some particular user interface, graphic user interface, so that we can see that what is going on. So behind this graphic user interface, you will have your code running. And we the people, we will see that how exactly graphically it looks like. Okay? Have you previously done any course on programming? Yes. Have you used programming to create some GUI, graphic user interface? No? That's fine. So remember that there are artificial intelligence, AI, all over the place. ChatGPT, if you ask them, they can write you a GUI, just right at the top of the moment. Okay? So utilize all of these things as far as you can. Take the full advantage of these AI stuffs. And you might be able to quickly create some codes and test it out whether your equations hold true and how the entire stuff look like in the user interface. So in the user interface, I'm expecting the following: that maybe this is your computer screen, and we're seeing the interface on the screen, and maybe one panel of your user interface will have the input value for Q plus and Q minus. Okay? So you are going to put some charge value, like it's a 5 coulomb charge or 1 coulomb charge or negative 1 coulomb charge, something like that. And then you're also going to provide an input to the small test charge, small q. You are also going to provide an input for how much mass that small test charge q has. Okay? So the mass of the small test charge, the charge, the positive charge and negative charge, everything should be there in your graphic user interface. And maybe you should also point out that how much distance is there between the small between the positive test charge and negative test charge. You may also need to point out what is the initial position of the small test charge from where you will start calculating the entire trajectory. Okay? So once you provide all these inputs, then your user interface will show how does it look like visually. So your user input will show this kind of graph. It will also show what are the electric field distributions. Okay? And in order to calculate the electric field distributions, we are going to use this fact. Okay? Remember that every time the Q changes its positions, this value is going to change. Okay? So it will be completely iterative process. And then you will place your small test charge Q at any position here. And then you will monitor how this small test charge Q is going to propagate with time. So eventually you will see if you plot time versus the position of an electron of the small test charge, how this guy is going to propagate. Maybe this guy would have this kind of relations. Or something else. I don't know. That you have to figure it out. Okay? But are you getting the sense of it? Like
so we have
exactly?
to plot that graph too?
Yeah, you can plot the graph. So we will both have the visual depictions, like how it moves, and how the graph looks like. In fact, this part is the easiest one.
Yeah.
The little bit challenging part could be this. But as I tell you that even if you do not work on the GUI previously, take the full advantage of AI, and we can also talk to each other in the office hours, and we will help each other. Okay? If you use Python, the Python has some very good module like Tinkercad, which can be leveraged for creating user interface. Okay? But the first thing is to first write the code. Even if you cannot show the visual picture, you should be able to generate the code. Okay? Like your first job is to create this graph. And once it is done, you know that everything makes sense, then you start working on this user interface. So this will be your final product that you can show to somebody, like a kid who even doesn't understand what is electromagnetics. So try to generate these kind of graphs. So this is one thing, and this is only a very small part of creating particle accelerators. We just described that if you put a test charge in an electric field, this test charge is going to have some propagations with time. But we need to accelerate it, and not only accelerate, we need to accelerate it in a particular direction. Right? So the second part of the project would be the following: that how we can accelerate a particle in a given direction. The previous guy that we talked about, it does not have any desired directions. You just put it there and try to see that how does it propagate. Once it is done, we now want to see that how we are going to control it. Now, if we want to control it, then maybe the best possible way is to use some ring structure which contains some charges. Let's say that this guy contains some charge density rho, and it has some radius. Let's say radius is r. And if we place a small test charge, small q, at a point P, which is at the same axis, which cuts the center of this circular disk, then this Q is also going to have, also going to experience some forces, right? So we also discussed how much force will be there and what is the direction of force if we put a test charge at an axis at the center of a circle. Do you remember that? What will be the direction of the electric field of this line at this point? Will it be this way? This way, right? So it will be straight to the x-axis and pointing away from the center, right? Or away into the center, depending on what is the corresponding charge of that beam. Now, if we use this kind of ring structure, now we have a very controlled way of calculating what is the trajectory of the small test charge. We know that this guy is going to move around on that axis, right? It's not going to move around in arbitrary directions. So this is very helpful for us. Now we know that how to control it. Okay? So tell me the following. Let us say that I take a negative charge density, I put it on a ring of charge, a ring of wires, and I place some small test charge at a point P, somewhat away from the center. This guy is going to feel a force into the center of the disk, right? So it will keep moving in. And we also know that the electric field for a ring of charge, if I am not mistaken, it is 2k rho divided by not 2k rho. I think it is rho BH divided by d square plus h square raised to the power 3 by 2. And probably there is some constant k, but I forgot that. Let me just write it k, but please check with your book that what is that constant. Okay? But typically this is how the electric field looks like, where let me change it instead of r, let me write it b, just to keep consistent with the equations. So this is b, the radius of the circle. This is h. H means the distance of the point test charge from the center. And once you get all these values, if you know what is the corresponding charge density of that ring, you can calculate the corresponding electric field, right? So, according to this equation, it tells you that if you put a test charge here, somewhere here, away from the ring of charge, this Q guy is going to have some propagations along this x-axis, right? And eventually, it will come to the very center of it. At the very center, what will be the corresponding electric field? 0. And how do you know from the equation? H should go to 0. Do you follow? The B is the radius. Let me write it this way. The B is the radius, and H is the distance from the center. Right? So, if this guy comes to the center, H is going to be 0. That's why electric field is going to be 0. So what is your thought? After Q reaches the center of this ring, is it going to stop? No? Why? There is no force. So let me explain the scenario one more time. You have a ring of circle. You put some test charge somewhat away from it. Because the ring of circle is carrying some charge, like maybe negative charge, the small positive test charge is going to come towards the center of it. At the very center, there is no force. The question is that what will happen to this small test charge? Is it going to stop? No?
It can oscillate.
Yeah.
It will oscillate. Why? Can you explain further?
Because it'll have the momentum to go to the other side.
Mm-hmm.
And then it'll come back because the electric field will be pointing towards the center of the circle.
Very
It'll
good.
just go back and forth.
Very good. So, once it comes to its very center, it's not going to stop. First of all, it has an inertia, right? Because this guy, this small test charge, like if you are trying to experiment it with a proton, this proton will have some mass. And we can calculate that how much inertia this proton has. Because of the inertia, despite it reaches the center, it will still keep propagating, right? Because of that inertia. But once it tries to get out of this, away from the center, again it will try to feel a force in the opposite direction. So pictorially, how does it look? This small test charge, let's say the proton, this proton will come close to this guy at the very center. At the very center, there is no force, but because of the mass, it will have some inertia, so it will still have some velocity. It will keep propagating to the same direction and try to get away from the center. But as it tries to get away from the center, now this guy, this proton, is going to feel some force in the opposite direction. So again, it will try to come back, right? And once it reaches the center, it will again go to the forward because it has some inertia, and then again it will come back. So it will keep oscillating around the center. Are you following that why it will be oscillating? Okay. And how to explain all of these oscillations? It's very simple. Again, you are going to use only these special equations from classical mechanics. That V would be U plus AT and S would be Vt plus S naught. S naught is the previous position. Have you seen this equation previously? Have you taken a course on classical mechanics?
Yeah.
Okay, very good. So you are going to be utilizing all these equations in your code. And once you put these equations into place, you will see that how this proton is going to oscillate with a period of time. Alright? So for this guy, if you try to plot time versus position, we are supposed to see that this guy, this proton, may have an oscillations around the center of the disk. So let's say this is the center, 0, and we will see an oscillations around the center of this disk by this proton. Okay. So this should be the corresponding graph if we put everything in the correct way. Okay. So this will be the second part of the project, that how the motion is going to look like if you place it somewhat away from a disk of circle. Okay. Anybody has any question up to this point, that how we're going to do that? So once you start programming it, then maybe you will get some more questions and we'll talk about it. Okay? Alright, so we know that if we only have two charges for a body, plus Q and minus Q, we'll have some motions, but those motions will not be very well controlled. In order to have a good control, we need to design a circle, and then we may place a proton here, and then we'll have a better control. But that's also not it. We say that we want to give that proton sufficient amount of energy so that it can bombard on your cell. So it cannot just simply oscillate around your device. It has to get out of your system, right, and get inside of your body. So how we are going to do that? So this small guy, this small ring of charge, this itself alone is not sufficient to create this huge bombardment impact. In order to create the entire device, we need to create something else, right? For instance, maybe instead of just one ring of circle, guys, can I have your attention? Thank you. So maybe instead of just one ring of circle, we may have to use multiple ring of circles. Okay? So previously we have seen that if we just use a single ring of circle, our proton is going to come close to this center and then it will oscillate around the center. That won't help. We have to create a continuous propagations for the protons from one place to another place. So instead of having a single disk of circle, maybe it's better if we have multiple disk of circles. So if I have two different rings, let's say the first ring has a negative charge, and we place some protons at a distance d. Because of the charge, this proton guy is going to come close to this guy, go to the very center, and because of the inertia, it will keep propagating. And now, we don't want this guy to go back. We want this guy to just keep propagating. So what we are going to do? Are we going to have the same charge here? If we have the same charge, this guy is going to come back. So we need to alter it. So that means we need to keep a very close eye at when this guy is going to get out of this center. Once it gets out of the center, immediately we need to change this negative charge to the positive charge. Right? So we need to design a device which will monitor the location of this proton, and as soon as the proton gets out of the point center, this guy must be changing the direction of this voltage. So let's say we are trying to provide a positive voltage on this guy previously. As soon as it gets out of the center, we have to change the polarity of this voltage. So instead of negative voltage, maybe we will be applying some positive voltage on this guy. If I apply positive voltage, then this proton will continue its propagations towards the x-axis, right? And the other guy, which is waiting somewhat away from this guy, this must have a negative charge. Why? Because we want that the proton must be attracted towards the other guy. And why we are using two different disks? Remember that we want a continuous propagation of the proton from one place to another place. So if I use only one charge, one disk of charge, this proton is eventually going to lose its momentum, even if I change its corresponding sign of charge. So in order to have the right momentum, we need to design actually multiple disks of charges, okay? So that this proton is never going to lose its momentum. It will just keep propagating along that line. So this is why at some certain distance, we will have another ring of charge, and we have to make sure that by the time this guy is changing its sign, this other guy is also going to change its sign. Let's say that our proton has just come out of the center of the first circle, then this guy must have a positive charge, because if we want this proton to get out of this center. At the same time, this other ring of charge, they must have a negative charge, because this guy wants to attract these protons. But by the time the proton reaches the center, we must change the sign of the charge for the second guy as well. Okay? And this will keep just going on. So we will have eventually multiple ring of charges. Okay? And all of this ring of charges will keep oscillating their corresponding voltage, so that the proton will always have the same directions of propagations. Are you following? So you understand that this is not easy actually. Making a particle accelerator is very, very difficult. How do you know that this proton is moving? How do you know which position the proton is at this moment? And at which point of time you are going to alter the corresponding voltage of this charge? These are very, very difficult engineering problems. Yes.
It's like how long would you have to keep that going?
So unless you have the certain amount of momentum. So let's say that I want, that's a very good question. So the question here is that how long do we want to keep this proton propagating? So you have to understand that you realize that the more propagations happens, the better momentum, the higher momentum the proton will achieve, right? So the more number of disks we use, the momentum of the proton will be higher, the energy of the proton will be higher. Now how much high the proton momentum should be, that depends on how deep we want to penetrate. So if our cancerous cells is very deep inside, we need to get a proton which is very, very high magnitude of momentum. Do you follow? If it is on the skin, then the proton momentum would be probably very little. We don't want the proton to get very deep inside. But maybe if it is very, very deep inside, we need to get this proton to have a very, very high momentum. Okay? So everything is very complicated engineering problems. Like that depends, like what kind of cancer you are going to treat, in which position of our body these cancerous cells are there, and depending on all that, you are going to find out that how much momentum you are going to provide for a small test tube. Okay? That will define that how many disks you are going to use, how much charge you are going to provide on this disk of circles. Okay? Yes.
This will be like just a line of rings, right? This is not going to wrap around into a ring of rings, right?
No, no. If it is wraparound, then probably the charges is going to take a circular path, right?
Right.
That's also another possible applications which people use. Have you heard of the name of like Large Hadron Collider? So they have a very big ring of charge because they want all these protons to collide to each other. But that's a different application. For now, I think let us just focus on a simple device. That's also not simple. Although I say it's simple, it's not simple. It's very difficult mathematics and very difficult engineering, right? And we have not even started to talk about non-ideality. So this is why this is not a single-man job. Like the project is a single-man job, but it is really the tip of the iceberg. In order to create this entire structure, we need an army, whole army, who will work on it day and night. Okay? But you understand that what is the significance of it? Like, if we can do it properly, we can solve a human problem, right? So, I think we talked about it a lot today. It's time for you to have some rest. So think about it. Think how we are going to design this system. First of all, we need to design a very simple system where we have two charges, a positive charge and negative charge. We will put a test charge and we'll see that how this test charge is going to propagate in that electric field. Try to design the corresponding graphical user interface using Python. Once it is done, then go to the next part. The next part is that now you have a ring of charge and you want to see that how a proton is going to propagate through this ring of charge. You should be able to see, if you do your math correctly, you should be able to see that this proton is going to oscillate around the center of that circle. And now the third part is, instead of having a same circle, what if you have multiple chain of circles? How this proton is going to propagate. Okay? And then eventually we'll be able to see that how exactly we're going to control this entire stuff so that the proton has some starting momentum, so that it hits and goes into a certain depth of your body. Okay? I know this is very, very difficult problem, but I hope that it will be very fun, very entertaining, and you will have a sense of fulfillment, which is much better than just doing some math blindly in your exam. Yes.
Do we need a graphical interface for the rings, for the line of rings? Do we need a graphical interface for that or not?
Yeah.
We do.
But think about the interface later. Think about how we're going to generate those graphs. Interface is actually not that difficult. Like, there are tools to use. Like, maybe you have to use some days. But the hard part is writing the code and getting the graphs.
When is it due?
So I think our last exam would be on 10th of December, probably, right? So on that very week, we should have the project. Okay. So this project will be individual. I'm thinking about the following. Like this is not everyone's cup of tea. I totally understand that. People who do not want to take this venturous path, it's totally fine. You still know that you have your quizzes, your homeworks, then your exams, and all of them will add up together to 100%. So don't worry about it. I know that and there is nothing wrong with it because many people do not have the time to invest on it. But I know there are also some people who is very adventurous, who wants to do something interesting, something fun, something more out of it. So they can do out of it. Okay? I know that because of the time investment, maybe you will not do very well in your exam, and that's okay. This guy is going to carry 25% marks. So even if you skip one exam, still fine. You can do your project and completely cover it up. Okay? But if you do not want to take that risk, that's also okay. Just take the exam and do the regular stuff. That's also fine. Eventually, you will be able to cover the entire 100%. If you are going to cover the entire stuff, like quiz, classes, exams, and all the projects, well, I cannot give you more than 100% marks, but maybe I'll be able to write a very good letter for you, okay? Which will be helping you in your internship or whatever it is. Yes, sir.
Is there like a specification of like energy level you're looking for?
Say it one more time, please.
Is there like an energy level or specification you're looking for that you have to get out of the?
So this will be all variables. Like if you design a program which says that if I am going to use 5 ring of charges, then I'm going to get this amount of momentum. So I'll keep it completely on you. Like once you get the program, it should be very easy to find out that how many ring of charges you are going to utilize, how much momentum it is going to achieve. So I'll keep it on you. Okay. All right. So keep working on it. As I said, If you are venturous, go ahead and try that. Actually, try that. Okay, give it a shot and see how it goes.
So if we do the first part of the project with the program, will we get
Partial.
12.5?
Partial one. That's a little bit of human judgment. Like you understand that the first part is probably not that difficult. The second part is a little bit more difficult. The third part is probably the most difficult part. So based on that, we will create some rubrics.
We still get a little song.
Of course, yes. We'll get something, of course.
Can you give us like a Word doc with like the steps?
Yes, yes. Very good question. So I'm going to provide a detailed descriptions of what exactly are supposed to be done, because I know that some parts might be missing, some people may not be following, and some people are not yet here today in the class. So I'm going to provide a detailed descriptions, maybe a one-page description of the projects, and I'll divide them into various chunks. Thank you. Any more questions? Okay, good. So as I said that try that thing. This is something new that I'm trying for you guys. And if we are successful, then we can actually show it up to other people that, look, we designed this. People often do not do this kind of design stuff. But I think it's time to show some energy and see that what we can do. I mean, if we can do it, it will create an example for your other people, for your juniors, who will follow, and maybe they will do something even more interesting out of it. All right, thank you guys. Yes, please.
So let's say that you of us start working on the project individually and kind of